Good morning. I'm Dr. Brickner, the instructor for Section 0W60 of Astronomy 2002, the online section for spring 2020. This little video is going to kind of give you a start, talk about some of the topics for the semester, some of the procedures. We'll go over the exam schedule, and at the end I'll talk about Nights Under the Stars, which is a UCF observing program. Now, many of you are probably thinking, well, why am I here? And of course, the answer to that is you're here because of the GEP program, General Education Program, Science Foundation E1. This course fulfills that requirement. And this is, the basic rundown of our topics and stuff. This is just a quote from the course catalog. Now, let's get started. For the first week, first thing I want you to do is take the attendance quiz. Get that done this week. It's called Homework Zero. It requires a little bit of reading about the Eagle Nebula. It's one question. Hopefully it's fairly easy. And go ahead and do that this week. And you can also start skimming the free textbook. Yes, the textbook is free. You don't have to pay it 200 bucks for it. Okay, when you go to the home page, here's what it looks like for this semester. You'll see below these images of the Aurora Borealis a list of study tools for the students. Now the syllabus is up there, iPhone calendars, prescription, all kinds of stuff. But the thing I want to emphasize right now is the free textbook. So you click on that link, okay, and then it'll take you to the modules page. Now our modules are the textbook. We're not going to hit every chapter verbatim front to back, but they're all in here, all the readings that we're going to do. For instance, if you go a little bit further down the module list, you'll see 3.4 orbits in the solar system. Yeah, we'll be reading about that and talking about it in the YouTubes on the lectures on YouTube. So if you click on that, this is what it looks like. So this is what the book looks like. Okay. And there's a couple other ways to view the book, but this is the one that should be easiest for you. Now, a couple things about this. I want you to start skimming the free textbook. Here's, figure 1 from chapter 3.4, a bunch of orbits. And so just eyeball those images and diagrams and so forth. And another thing that you'll see are my annotations in the textbook. Now, they look like yellow highlights, okay? And some of them are only highlighted text, for importance, but a lot of them have actual text that you can look at if you click on them, okay? And so you click on them, and I built these up over the summer of 2019 and fall of 2019. And I'll probably be putting in some new ones this semester as I go through the book. And the important thing about the annotations is that a lot of times they'll link out to a homework or to another web page. Sometimes they'll have images that I talk about in the annotation. And it really tells you what my emphasis is, the things that I'm concerned about. And of course, that's important to know because that tells you the kind of thing indirectly that I'm going to ask you on exams. That's what exams are. Trying to figure out if you savvy the important stuff that I go over in the YouTube lectures. Now, speaking of YouTube lectures, there's a link for that on the homepage as well. You can look at that. I want to emphasize today 2 ideas to keep in mind throughout the semester. The first one is black holes and how we find traces of them. And everybody wants to know about black holes and stuff. And just a short while ago, we imaged one in the center of galaxy M87. And what's interesting for us is that by studying the chemical and nuclear composition of asteroids and comets in our solar system, we can trace back to other star systems that today may have become a black hole. So, um, chapter 3.4 is a case in point. The orbits that we study in the solar system are due to gravity of the sun, the gravitational field of the sun. And black holes have a gravitational field, and things orbit black holes. Not everything gets sucked in. Now, if it's far away, it doesn't necessarily have to get sucked in. And those orbits tell us a lot about the black hole. So we're always going to be thinking about that this semester. Now, another thing that we're going to be thinking about is the Stardust Spacecraft. And that is a spacecraft that a few years ago we sent out into the solar system to look at stardust. In other words, particulate matter that we could scoop up just by flying through space. Now, here's a little rundown of the solar system. This is from chapter 14.3. And it lists a bunch of different minerals that we know are on different planets. For instance, olivine is hugely abundant in Earth's crust and mantle. It's a big part of the crust and the mantle of the Earth. So, and we could see that on other planets, like Mars and stuff like that. Now, the Stardust spacecraft, here, take a look at this little dealy bobber up here. Okay, now it looks like a tennis racket, and it is about the size of a tennis racket. And what it is a this roundish object has a bunch of rectangular slots, and in those slots are something called silica aerogel. It's very light, and that's where the stardust particles get collected as we fly through the solar system. Now, this particular spacecraft is important to us because here, the whole thing, the whole plan of this Stardust spacecraft was to fly through the tail of Comet Wild 2. Right now, here's a diagram of Comet Wild 2. And you can see Earth's orbit down there, and there's the sun down at the center and stuff. And it took a couple loop-the-loops as it was heading out to Wild 2, and it went through Comet Wild 2. And then we got it back to Earth. It was designed to eject the collection capsule and parachute back down to the surface of Earth, just like astronauts coming back from the space station. Now, here's the interesting thing. What we collected from Wild 2 is tied up to almost every single topic that we study this semester. And so it's something that I think about a lot. And it tells us an enormous story. It gives us inkling just from studying things that we find in our solar system, things way far away on other stars and in other galaxies, like that black hole in galaxy M87. Another thing that is reminiscent of Wild 2, now that's comet stardust collection. Another thing that we do similar to that is analyzing meteorites that fall to Earth. Now, a lot of those, for instance, we know are from Mars. And here's a bunch of scientists down in Antarctica, trying to find it. Apparently down there, it's very, very easy to find rocks that fall to Earth. And because everything's white down there, all that snow and ice. So it makes rocks. Now, I don't think all those rocks are meteorites, but I'm sure that's what they're looking for. And we've found a lot of a lot of meteorites in Antarctica, including some that are from Mars. So it's really good. And that's how we know, some of the rock formations on Mars. Now here's NWA 2626. It was NWA means Northwest Africa. It was discovered in Algeria back in 2004 by civilians, people that lived out in the outback in Algeria. And this one we know is from some of the volcanoes in the Tharsis, Tharsis area of Mars. Yeah, that's a piece of a volcano that an asteroid impact or maybe even a volcanic eruption blasted into space. And it was on just the right trajectory to fall to Earth in Algeria, and somebody picked it up in 2004 and brought it back, and we've been studying that one. So the nice thing, the other nice thing about meteorites and stuff is you can become a meteorite hunter yourself. I mean, here's a picture of a amateur astronomy club gathering. They're getting ready for a night of stargazing. Now, I believe this one's up in New Jersey, but we have groups down here in Florida as well for using telescopes and just plain old stargazing. And amateur astronomers, which you will be at the end of this class, they way outnumber the professionals. And they do plenty of discovering and imaging that the pros cannot do. So you see this movie Deep Impact from 1998, which was pretty good. Frodo before he became Frodo, was about a comet impact, all right, discovered by this young man. Plus, he had a girlfriend and all that kind of Hollywood stuff. But that stuff definitely happens. Astronomers, amateur astronomers, all the time. Matter of fact, one of the recent supernova discoveries was discovered by an amateur with a fairly nice telescope, but nothing like the Hubble. It's just something he could operate in his backyard. All right. Now let's turn away from the topics of the semester. Let's go through some of the basic procedures. Probably wondering about how everything works, grades and all that. So the basic procedure, we're going to have midterms and a final course. So what you're going to do, you're going to view and study the lectures in YouTube. Now these are from spring of 2018, so they're 2 years old. Next time I teach an astronomy lecture class, I'll be re-recording. This is the most, and usually I have it a little more often, but the last year or so I haven't been assigned to astronomy lecture. But I'll probably be assigned next year sometime, and when I do, I'll re-record. But for now, we'll use the spring of 2018 lectures, and they're perfectly fine. It'll be like you listening to me in class. Okay, so you'll also do reading in the studying in the pertinent sections of the textbook. Now, that's our free textbook. Okay, once you combine those two learning experiences, then you can tackle the homework. Now, we're not going to have a ginormous amount of homework, but we will have some before each midterm exam. And after that, you can circle back and restudy and re-listen to the YouTubes. And then eventually, hopefully, you'll be ready to tackle the midterm. Right? So that's basically the basic process of the course that you'll be doing. All right. Unfortunately, you won't be in lecture with me, but you will be able to do this. Okay. Now, the variation is that we occasionally have online office hours for questions, practicing calculations. And even though the calculations are not going to be bodacious, there's a huge variation in math experience. So, a lot of people like to have extra practice, and a lot of times we do that in online office hours. And I'll show you how to do that as the time comes through. Now, speaking of midterms, let's look at the basic set of midterms. We have 3 of them, all right? We have homework, which I'll convert it to 50 points, same size as a midterm. 3 50-point midterms, and then a 100-point final. Total of 250 points for the semester, because we're going to take the best 2 out of 3 midterms. So, and you can read more about that in the syllabus, how that works. So those are our basic tasks. That's what you'll be doing. You'll be doing some homework, some midterms, and a final. All right. And unfortunately, we won't have any um, a chance for all of us to go to the observatory on campus because not all of you are on campus. That's all right. But we have other activities that we can do. Now, here's the grade scale for the semester: 90%, 75%, 60%, 50%, etc. So in terms of the points, 90% of 250 is 225. 75% of 250 is 188 or more. 60% of 250 is 150. All right, so if you want to get a C or higher, you got to nab 150 points. D or more is 125, half of the available points. Below that is an F. And just so you know, I don't grade on the curve, and I have major objections to that. So don't worry about that. If you keep up with the work and you study a little bit every week, every day, and don't let everything, all the homework and reading, don't leave all of that for the last minute. But if you do a little bit, a few hours per week, studying and reading and doing homework and talking to me and in discussions and stuff like that, you'll do all right. The people that get Fs are people that A, don't spend any time in the class, B, try to do everything at the last minute before each midterm. And C, people that um, they blow the exams. I mean, they don't come. You know, we have an exam schedule, and they say that nothing is written in stone, but that is not correct in this class for sure. What is written in stone for us is our exam schedule. Here it is. Midterm exam 1 is January 30th. Now it opens at 10:05 a.m. and you get an hour to do it. But you can start later in the day. The only requirement is you have to submit your exam before 11:59 p.m. That's the deadline. So you could actually start it at 10:59 p.m. and get a full hour and submit it at 11:59 p.m. and you're good. Right now, that's the same timing availability for all three of the midterms. The second midterm is Thursday, February 27th, right? And the third midterm is Thursday, April the 2nd, 2020. So they're all Thursdays, they're about a month apart. And if you miss one of them, um, it's okay because we keep the best 2 out of 3. So if you're there for exam 1 and then you can't make it to exam 2, but you do make it to exam 3, you're golden. I mean, if you get a good grade, anyways, you'll have grades for that. It's if you miss more than one exam, then you're toast, right? And so there's a lot of flexibility in this. There's at least 14 hours of availability for each midterm. Okay, so if you have an 8-hour-a-day job, that gives you another 6 hours to get home or get up to campus, get some food, take a little nap, and then still have an hour for the midterm before the deadline. All right, so you've got to manage that. And in recent semesters, I've had to give Fs to astronomy students that blew off exams. They just didn't program it into their calculator or whatever, and they didn't come to exams. They didn't take exams. All right, and I don't know how you expect to pass, but you've just got to do it. All right, now the final exam, it cannot be dropped. That's one everybody has to take. That's mandatory. All right, it's also cumulative. Now I'll give you a little more time on that one. It starts on the Saturday of finals week, so that's usually what they call a university free period. So we start at 8:05 a.m. For availability, and then again you have to submit it before 11:59 p.m. Right? So that's what? 16 hours of availability. So if you have an 8-hour job and you got to make it to the final exam, you don't have an excuse. And I don't care what job you have, 16 hours is not, nobody's going to work 16 hours. Not even you guys that work out at Disney. But if you're in the hospitality management minor or major and you're working out at some resort like Disney or some other resort, you've got to get your schedule fixed on these 4 dates. You have to ask your boss now and get it squared away. All right, you've got to have time for the exams. Now, the final exam is twice as big, it's 100 points, but you get 2 hours and 50 minutes, 170 minutes to complete it. So it's not quite as tricky as taking a midterm. The midterms won't be bad either. I mean, most people, 60 minutes is plenty of time. So just to review, there are no makeup exams either. So if you miss midterm exam 1, do not ask me to make it up. There's no early exams and there's no late exams. Okay? I'm not going to schedule, we get a huge number of students in this class, so I'm not going to schedule early for John Doe or late for, you know, Jane Doe or anything like that. This is in stone. This is our schedule. These are the only exams that we're going to take. All right? Now, let me re-emphasize the final exam. For us, it's Saturday, April 25th, right? It becomes available at 8:05 a.m. You have to submit it by 11:59 p.m., right? So that time, you've got to get a 3-hour block of time between 8:05 a.m. and 11:59 p.m. So ask your boss, tell him Dr. Brickner is an SOB about it. He never budges, and I'll give you an F if you don't make it. I mean, you just got to make it, all right? You've got to get your schedule squared away, all right? If you're on a sports team, you got to get this stuff done. You got to, coordinate with your academic advisor, right? Now the final is double the size of a midterm, as I mentioned, and you get 170 minutes for it. But you've got to schedule it. You've got to be there. You cannot drop it. It's mandatory. And if you don't get it, you're probably not going to get a passing grade. Now, if you ace everything else in the class, yeah, maybe you can get, pull out a D or something like that. But it's 40% of your grade, so you know, it's, you just got to be there. It's mandatory. So totally engrave that into your mind. All right, now inside web courses, I've set up a little WebCal link for those of you that have an iPhone. You can automatically program in homework assignment dates, due dates, and exam dates in your iPhone. And just go ahead and look in the little, I don't know, calendar. It's called Hubble's Vision. It's a little WebCal link, and I've already set it up for you so you can, get that in your phone. If you have an Android phone, I don't know, maybe you can use it. All right, so that's the basic exam procedure and points and everything, grade scale. Now, I want to give you a little blurb about the UCF Astronomical Club, the UCF Astronomical Society. And they have, here's a little blurb, you can screenshot that if you want. The astronomy observatory is on campus. It's down past the water tower, past the campus police, and then you make a left and you kind of go in by a bunch of agriculture buildings, I guess. And then it's back there, a little dome building. It's pretty good. It's a nice little, you see a picture of it there. And what they do, the Astronomy Society, they have public observing nights. Now, if this were a lecture class, I just tell everybody, see if you can go. All right, look at the schedule, see if you can go. All right, and I don't know about this astronomy camping trip business, but uh, but maybe you can go on one of those too if they have it. And they have a nice website, and they have a schedule there. And I've linked the schedule. There's a page called Other Study, no, Stargazing Study Tools in our website, and you can look at that. It's got a link to their schedule and stuff like that, and a few other things. And plus, they have Facebook and Instagram and whatnot. But that's a really good place. Now, it's optional. It's not a requirement. And if you're not in Orlando, of course, you don't even have a shot. But if you are on campus or around Orlando this semester, you could give it a shot. And Orlando's not the best place for stargazing and using a telescope within the city limits. But we usually get a few, especially in spring semester, we'll get a few good nights for observing, and they're usually on Wednesday nights. So if you can go, and you'll learn a lot, and you might make a few friends. You might even turn yourself into an amateur astronomer. And if you're not in Orlando, just if you're out in Texas or you know the Philippine Islands or who knows, just ask around. There's astronomy clubs everywhere, and there's observatories, planetariums, science museums. Just ask around, do a little, and you can learn a lot. And a lot of the stuff that we talk about, I'm always looking at the stars myself. Well, every clear night when I get home, I'm looking at it, Orion and the Big Dipper, the Pleiades and stuff like that. And these you can learn a lot because a lot of stuff I'll talk about, I'll say, I'll be talking about, well, Orion is up in the sky right now after dinner, or Orion's coming up just after sunrise, et cetera, depending on the time of year. So yeah, you can learn a lot by going to one of these observatories. All right, that's all I got for now, and just welcome aboard, and I'll talk to you through the semester.